where does this function f of x have a removable discontinuity? Remember, that's also talking about kind of like a hole in the graph. And what function g of x would agree with f of x and be continuous everywhere? So what we're going to have to do is figure out if there's a hole here, where's that hole at? I think from looking at the denominator, we can see that the possible hole is going to be where we have 3. So let's do a limit as x approaches that value for this function and see if we can solve this out and try to see what that value would be. That's going to require us, it looks like, to do some factoring here. So let's factor out first the greatest common factor of x. And then let's continue factoring the rest of that into 2 terms here. It looks like it would be x minus or plus 7 and x minus 3. Now we can get those to cancel out, and we can see what the rest of this would be. If we continued solving and now plugged in 3, it looks like we get 3 plus 7 is 10 times that is 30. So at x equals 3, we should get it to equal 30. So there is a removable discontinuity. At x equals 3, or a hole. And then the function g of x that would look like f of x except without the hole, that would be kind of like this remaining stuff here. So g of x equaling this should look like our function that we have except not have that hole, or if you multiplied that out, this function here looks exactly like this function except it doesn't have the hole in it.